Today we're going to focus on square roots. We're going to work with radical expressions and equations, not just rational expressions and equations. We're doing radical expressions and equations. We're really going to look at how not all operations are invertible. You can't undo every single operation, which is really what we've taught you in algebra. Everything you do, you can undo by doing the opposite. Squaring both sides, square rooting both sides, etc. But when you square both sides, you might get an extraneous solution, an extra solution that doesn't really work. But let's get into it and see what we can do. Okay, for exercises 1 through 4, describe each step taken to solve the equation. Then check the solutions to see if they're valid. If not valid, tell me why. Okay, so here we added 6 to both sides, going through some basic algebra here. Right? And then we squared both sides. To get rid of a square root, we can square things. And let's go ahead and check it. So square root of 100 minus 6 equals 4. I have 10 minus 6 equals 4. Therefore, 100 is a valid solution. Okay, let's try the next one. So again, we're adding 6 to both sides. And then we're taking the cube root, we're cubing both sides, not the cube root. When we're trying to get rid of a cube root, we cube. If you're not sure where to find that on your calculator, I can show you tomorrow. Let's go ahead and check it. Cubed root of 1,000 minus 6 equals 10. 10, oh goodness. Let me start over. I like to set things up a certain way. So 1,000 is a valid solution. Okay, I moved numbers 3 and 4 to the next slide. Okay, so minus 6, square root of x equals -2, square both sides. We have x equals 4. Let's check it. Square root of 4 plus 6 equals 4. 2 plus 6 equals 4. So 4 is not a valid solution, because that's not true. Minus 6, cubed root of x equals -2. Cube both sides. X equals -8. Let's check it. So cubed root of -8 plus 6 equals 4. -2 plus 6 equals 4. So -8 is valid. See why you need to check. Algebra, you think you're doing great, but when you go to plug it back into the equation, it doesn't actually work out. So what did we do first? We always isolate the radical. Just like when you're solving for a variable, you want to isolate the radical. And then once the radical is isolated, you're going to square or cube to eliminate. Oh goodness. The radical. And it's just our basic algebra steps, but we're getting rid of something different. In fact, even if you had like a 5th root of something, you would raise it to the 5th power to get rid of it, okay? Okay, let's do our first example. So work through the example to solidify our steps in solving a radical equation. We're going to do the steps that I just talked about very briefly, where we isolate the radical, and then we square or cube or whatever we need to do both sides. Make sure that we can justify what we're doing. So I'm isolating the radical first, moving over here. Add 2 to both sides, I get 1. Now I need to square both sides. 3x plus 5 equals 1. Now go ahead and continue to solve. So x equals negative 4/3, and we do need to check to make sure that it works. 3 times negative 4/3 plus 5 minus 2 equals negative 1. Here, those cancel out. I'm at negative 4 plus 5, 1. Keep going. Oops. Caught my mistake. Square root of 1 is 1. 1 minus 2 is in fact negative 1. And it checks. Okay, this is in fact a solution. So let's talk through this. What did I do? First of all, I isolated the radical on one side of the equal sign. Sorry about that. I isolated the radical on one side of the equal sign. That allows me to eliminate the radical by squaring without having to FOIL anything. It's just very easy if the radical is all by itself on one side of the equal sign. By squaring this, it basically gets rid of the radical sign. Okay, very, very simple. Once I get rid of the radical sign, then I go back to my algebra roots and I go ahead and solve for x. Then once I'm done solving for x, I really need to plug it back in and make sure the math works out. I don't want an extraneous solution. Okay, you're going to see that word a lot. Extraneous solution. Okay, that would be a solution that doesn't work. A solution that is not valid. Okay? Okay, we've got 10 examples. The first 8, we're going to work through a few of them together, and then you're going to go ahead and try some on your own. Be sure to check your solutions. I'll do 5 and 6 with you, and then I'm going to set you off on your own a little bit. So first, I've got the radical already isolated on one side of the equal sign, so I can go ahead and square both sides. I have 2x minus 3 equals 121. Add 3 to both sides, 124. Divide both sides by 2, 62. Now I need to go ahead and check it. If I plug 2 times 62 minus 3, I have 124 minus 3, 121 is in fact. It works. Okay, this time I'm going to cube both sides because it's a cubed root. To get rid of a cubed root, you need to cube. 6 minus x equals negative 3 times negative 3 is positive 9 times negative 3 is negative 27. Subtract 6 from both sides. I have negative x equals negative 33, or x equals 33. Let's go ahead and check it. Cubed root of 6 minus 33 equals negative 3. 6 minus 33 is negative 27. The cubed root of negative 27 is in fact negative 3, and it works. All right, I'm going to push pause. Go ahead and try 7 and 8 on your own. Okay, for number 7. First, I isolated the radical by adding 9 to both sides. Excuse me. So that gives me square root of x plus 5 equals -3. Then I square both sides. X plus 5 equals 9, x equals 4. Then I went ahead and checked it. 4 plus 5 equals 9. Oops. There's a mistake of mine. 4 plus 5 equals 9. Square root of 9 is 3. 3 minus 9 is not -12, so luckily I still got the same answer. 4 doesn't work, so there's no solution. Okay, let's look at number 8. It's already isolated, so let's go ahead and square both sides. 4x minus 7 equals 3x plus 9. It was very easy for me to add 7 to both sides, subtract 3x from both sides, x equals 16. I plugged them in to check my work and got square root of 57 equals square root of 57, so in fact, I am good. Okay, 4 more. I'm going to go ahead and push pause, do 9 and 10, and then record, and then 11 and 12 and record. So we'll do 2 at a time. If you want to go ahead and do all 4, that would be great, but I'd love you to practice on your own. Okay, the first one, my first clue that this wasn't going to work is that I had a -12 out front and a positive answer here. But I went ahead and did the work. I squared both sides, and note, I can, if I have a coefficient in front of the radical, I can square it. That means we square the coefficient and we square the radical. So the radical sign is, excuse me, canceled out. -12 squared is 144. I can distribute that. So I have 144x equals 1,188. I get a decimal or a fraction. I went ahead and plugged it in using my calculator and saw that there was no solution. I think I actually got as a solution -18 equals 18, which doesn't work. Okay, next one. I went ahead and divided the 3 by both sides here because it was an easy division. The 12 didn't go into 18, so I didn't do it. So that gave me cube root of x plus 2 equals 4. I cubed both sides. X plus 2 equals 64. X equals 62. Checked my work, and I was good to go. Let's try 11 and 12. Okay, number 11, the radical was already isolated, so I squared both sides. Got x squared minus 5 equals 4. Added 5 to both sides. Square root of both sides. I have x equals plus or minus 3. I went ahead and checked both, and because the negative is squared, it becomes a positive, and both positive and -3 works out. And next, they're already isolated, square both sides, x squared plus 8x equals 9. Subtract 9 from both sides, go ahead and factor it, solve both sides, and I was nervous, one was positive, one was negative, so I went ahead and checked both of them, and they both work out. So your solution is both 1 and -9. Right, compute each product and combine like terms. We have to FOIL these. So let's go ahead and FOIL them. X squared times x squared is just x. Sorry, rewind. Square root of x times the square root of x is x. Then I get minus 2 square roots of x plus 2 square roots of x minus 4. These cancel out, and I'm left with, x minus 4. Okay, square both these. X square root of x times square root of x is x, plus 4 square roots of x plus 4 square roots of x plus 16. Simplify. Oops. Well, let's rewrite that. And finally, okay, now we're going to rationalize the denominator in each expression. So we need to write the expression so there is a rational expression in the denominator. That basically means that we cannot have radicals in denominator. Okay, it's not allowed. So to rationalize them, we actually multiply them by themselves. Okay, we just did a bunch of examples that said if we square a radical, then the radical gets canceled. So I'll show you every step this time. We have x minus 9 times the square root of x minus 9 over square root of x minus 9 quantity squared. And now that we know that that cancels out, we have squaring the radical cancels the radical. X minus 9 times square root x minus 9 over just plain old x minus 9. And since I have this in the numerator and the denominator, and there's no addition or subtraction between them, we cannot divide out if we have addition or subtraction. I can divide that out, and I'm left with the square root of x minus 9. All right, so let's try another one. I'm going to multiply the top and the bottom by square root of x minus 3. Square root of x minus 3. No, I did not make a mistake, but we learned a long time ago that if I multiply positive and negative, I get difference of two squares. That's what I'm looking for here. It's a great way to get rid of a radical and to get rid of it with no middle term. So this time I have to FOIL. X minus 9 times square root of x minus 3 all over square root of x plus 3 square root of x minus 3. So let's go ahead and FOIL the numerator first. X square roots of x. Let's see, minus 3x minus 9 square roots of x plus 27. Now the denominator, square root of x times the square root of x is just plain old x. Then I get plus 3 square roots of x minus 3 square roots of x minus 9. Notice those cancel, and life is grand. The numerator is just a bit messier. I'm going to collect like terms. I have x square roots of x minus 9 square roots of x. I can't actually add those together, but they're near each other, which is nice. Minus 3x plus 27 all over x minus 9. I have the feeling I'm running out of room. On these first two terms, I can factor out a square root of x. I'm going to come right here. Square root of x times, I'm left with x minus 9. And on these last two terms, I'm going to factor out a 3, and I'm left with x minus 9 all over x minus 9. And I'm going to cut and paste to the next slide because I don't want to try to squeeze it in. So this is where I was in the last slide. If you notice, I have an x minus 9 that I can now factor out. It's factoring by grouping. X minus 9 times the square root of x minus 3 all over x minus 9. I can divide the top and the bottom by x minus 9 because there's no addition and subtraction between them, and I'm left with the square root of x minus 3 as my answer. Fantastic. So what we've learned today, to rationalize, because you're going to be told to rationalize these expressions, that means we need to remove the radical from the denominator. So when you see that in instructions, that is what you're looking for. An expression with no radical in denominator is rational. Okay? Okay, rewrite this in an equivalent form with a rational expression in the denominator. Okay, I'll do this one along with you. You can fast forward if you got it. This one's a little easier than the last example we did. Oops, if I write it down right. So we're going to multiply by the square root of x plus 5 over the square root of x plus 5. It's the best way to get rid of the roots in the denominator. I'm left with x. If I'm foiling, my center terms are going to cancel out because I'm going to have a positive 5 square roots of x and a negative 5 square roots of x. And then minus 25. In the numerator, I have square root of x plus 5. And I can actually do no more with that one. Life is grand. Okay, solve the radical equation. 3 over square root of x plus 3 equals 1. You can multiply by an equivalent fraction or just cross multiply. I have square root of x plus 3 equals 3. Then I can square both sides. X plus 3 equals 9. Subtract 3 from both sides, and I get x equals 6. Let's go ahead and check it. 3 over square root of 6 plus 3 equals 1. 3 over the square root of 9, 3 over 3 does equal 1. Without solving the radical equation, how could you tell that it has no real solution? Square root of x plus 5 equals negative 9. There's actually no way for me to get a negative when all of my numbers are underneath the radical, because, I don't know, if I take the square root of anything, I will not get a negative answer. It's just impossible. I can take the cube root of stuff and get a negative answer, but not the square root. All right, that's it. We learned to isolate the radical to solve. We also learned to rationalize expressions, and sometimes we multiply by a binomial with the opposite signs. That's it for today.